All right, so let's look at this exam question about linear momentum and collision, which is saying two cars crash head-on into each other and both come to rest. The momentum after the crash is 0 kg meter per second. The diagram shows the velocities and masses of the two cars before the collision. Calculate the velocity of car A before the collision, VA. Momentum is conserved. Momentum is conserved. Okay, so this is a question about linear momentum and collision. So the keywords that we're supposed to get from here is that after collision, these two cars are immediately coming to a stop. And if the two cars are coming to a stop, that means the magnitude of the final momentum, the magnitude of the final momentum is equal to 0 kg meter per second. This is what they've already highlighted here in the question. So that would be 0 kg meter per second like that. And if that is the case, what does that mean? In a scenario where we've been given, or in such a scenario whereby we've been given two vehicles that are moving in opposite direction, and immediately they crash into each other, they are coming to a stop. What does that mean? That means the two vehicles must have the same momentum. They should have the same momentum or the same magnitudes of momentum. It's just that the directions of momentum are opposite. That means the momentum of car A and the momentum of car B are similar in magnitude, but they're opposite in direction. Yes, so we're applying the principle of conservation of momentum. That means the initial momentum should be equal to the final momentum. But the most common mistakes that students make when handling such questions is that they forget to assign directions when it comes to velocities. So like in this particular case, we have this vehicle that is moving to the right and this vehicle that is moving to the left like that. Even when assigning the velocities of the vehicles, we're supposed to consider the directions because momentum is a vector quantity. So in this particular case, we're going to follow the directions based on the x axis, the x or the negative x direction, but also the positive x direction. So in this particular case, since car A is moving to the right, what does that mean? That means we are going to have this velocity as a positive velocity since it's moving in the positive x direction. Whereas for car B, it's going to be negative velocity since it's moving in the negative x direction like that. So this is what we have. So what are we going to say? Using conservation of momentum, we know to say summation of initial momentum. Summation of initial momentum should be equal to the summation of final momentum like that. So if this is what we have, we know to say momentum is equal to mass multiplied by velocity. And we have two masses. We have mass A for car A and mass B for car B. So I'm just going to write that directly. We'll say our mass A and velocity A plus mass B multiplied by velocity b will be equal to 0, since they've told us to say after the crash, the momentum is equal to 0 because there is no velocity after the crash has taken place. So we're going to consider this as -9 like that, and we already have the masses. So mass A is 1,000 kilograms. I'm just plugging in what we've been given now. 1,000 kilograms multiplied by velocity A plus 1,500 kilograms multiplied by velocity, which is -9 meters per second. This should be equal to 0, like this. Okay. So what am I going to have? I'm going to have 1,000 velocity A minus, let me just multiply 1,500 multiplied by -9. This is giving me negative 13,500. And this should be equal to 0. Okay, so now I take the negative 13,500 to the right-hand side of my equation. I'm going to have my 1,000 velocity A velocity A being equal to 13,500, like that. So I'll divide both sides by 1,000, even that side by 1,000. that will cancel out. That means my velocity A is equal to 135 divided by 10. This is 13.5 meters per second. You can see to say the value of our velocity is positive, which is justifying our initial assumption or our initial assigning of the directions to say this should be directed towards the positive x-axis, which means it's a positive velocity, just like that. So that, ladies and gentlemen, is how you solve this particular question. The most important thing you're supposed to do is to take note of the directions. If the vehicle is traveling towards the negative x direction, your velocity should also be negative. If your vehicle is traveling towards the positive x direction, even your velocity is supposed to be positive. So if two objects are coming to rest after collision, their initial momentum should cancel out, which is the principle that we used here in order for us to come up with this particular formula. And once you understand these simple principles, you should be well and okay when it comes to questions under collision, but also linear momentum, as simple as that. So yes, um, thank you for watching the video. Make sure to subscribe to the channel and don't forget to register with us as we continue to prepare you guys for your tests, your quizzes, your exams by giving you the best solutions to your materials. So thank you very much. Until next time, stay blessed.